All right, let's look at this definite integral right here. So I'm noticing that we have an ln x and also a 1 over x. So that's usually a hint that our u value could be ln x. Then du dx is going to be 1 over x. So dx is going to be x, oh dear, du. Now, if u is ln x and x equals e, then that means u is going to be ln e, which is 1. And if x is e squared, then u is going to be 2. So my new integral is going to go from 1 to 2 of 1 over x times u times x du. X's will divide out, and I will get the antiderivative from 1 to 2 of 1 over u du. And that gives me ln of u. I can drop the absolute value because I'm only plugging in positive numbers. And that gives me ln of 2 minus ln of 1. ln of 1 is 0, so I should just get the natural log of 2. Again, I'm going to erase, so hopefully I can keep this computer running. Okay, this one. This looks more like an arctangent situation, so let's rewrite this as the integral from 0 to 1 of x over 1 plus x squared squared. So we're going to let u be x squared. So du dx is 2x. So dx is du divided by 2x. If x equals 0, u also equals 0. If x equals 1, u also equals 1. So our limits of integration will not change. And we will now have x over 1 plus u squared times du over 2x. X's will divide out. Antiderivative from 0 to 1 of 1 over 1 plus u squared du, which is arctangent of u evaluated between 0 and 1. So arctangent of 1 minus arctangent of 0. Okay, so this is asking what angle gives you a tangent of 1? That's pi fourths. And what angle gives you an arctangent, or sorry, gives you a tangent equal to 0? That's 0. So I end up with pi fourths as my answer. Okay, very good. Okay, just a couple more problems here, working hard. Snow falls on a driveway at a rate of s of t equals 2 to the t inches per hour. Wow, exponential growth for 3 hours. Find the total depth of the snow accumulated over this 3-hour period. So if you want to find the total accumulation, we want to integrate from 0 to 3 of 2 to the t dt. Total depth of snow accumulated, yes. So, and then that is going to be the antiderivative of 2 to the t is 2 to the t times 1 over ln 2 evaluated between 0 and 3, which is 1 over ln 2 times 2 cubed minus 1 over ln 2 times 2 to the 0, which is 1 over ln 2 times 8 minus 1, or 7 divided by the natural log of 2 inches. And I'll let you get a decimal approximation for that because I don't have a calculator currently ready. Temperature of a metal rod is changing at this rate, degrees Celsius per minute. Find the total change in temperature during the first 10 minutes. That's going to be the integral from 0 to 10 of negative 10 e to the negative 0.1 t dt. Okay, so find the antiderivative, leave the negative 10 out front. The antiderivative of e to a linear function is just e to the linear function divided by the slope of that linear function, evaluated between 0 and 10. Of course, dividing by negative 0.1 is the same as multiplying by negative 10. So that should be 100 e to the negative 0.1 t between 0 and 10. And that's going to be 100 e to the negative 1 minus 100 e to the 0. So that should give me 100 over e minus 100 degrees Celsius would be the total change in temperature. Marginal cost of producing X units is modeled by this many dollars per unit. Find the increase in total cost when the production level is raised from 4 to 9. So we'd say the integral from 4 to 9 of 5 plus 2 over x plus 1 dx. So the antiderivative of 5 is 5x, and the antiderivative of 2 over x plus 1 is 2 ln absolute value x plus 1 divided by 1, which obviously doesn't matter. And now I'm going to evaluate that between 4 and 9. So I'm going to get 5 times 9, which is 45, plus 2 ln 10, minus 5 times 4, 20, plus 2 ln 5. So that's going to be 25 plus ln of 100, because I'll make that ln 10 squared. So I just combined the 45 and the 20 to get 25, and I just simplified 2 ln 10. Now I'm going to do minus ln of 25, because that would be 2 ln 5. And then using a property of logarithms, I can say that that's 25 plus ln 4 dollars, right? Because I can divide 100 by 25. Alrighty. Finally, matching. A local botanical garden is hosting a spring bloom event. Visitors enter the garden at a rate modeled by R of t, where t is the number of hours since the gate opened at 9. Match each mathematical expression on the left with its correct interpretation on the right. So 0 to 4 of R of t would be the number of people that come in between 9 and 1. So that's this, goes with this. R of 4 is how quickly people are entering at 1 p.m. That's this right here. The rate at which the arrival rate is changing at 1 p.m. So that's this right here. And finally, the equation used to find the time t when the total number of people who have entered reaches 500. That is this right here. Okay, so we matched it up, and that is it.